So good evening. There was no chance, but not by chance that it was Mendelssohn that they start with this evening spent on explaining the science behind musical prodigies. And there has been a lot written about Felix Mendelssohn, and one of those, many consider him not the second Mozart in time, but really the first really genius of music. And by Goethe said of him that really musical prodigies, as far as mere technical execution goes, are probably not so rare. But what this little man, Mendelssohn, can do borders at the miraculous. And I could not have believed it possible at so early age. And comparing the music that Mozart was writing as a child to Mendelssohn at the same age is like comparing the prattle of a child to the cultivated talk of a grown-up person. So this situates you the background. We are really working with the genius. What you may not know, and I didn't know, and this is really relevant to the neuroscience behind it. It's the born part of it that is what determines someone to become a musical prodigy. And Mendelssohn had a sister, and they are the only siblings who could both be regarded as the very highest category of child prodigies. And now comes the maid, or the environmental or the nurture factor. Felix Mendelssohn was really praised for his gifts, but Fanny Mendelssohn was forbidden to publish her compositions to prevent her from becoming ambitious and compromise the feminine virtues of love, obedience, tolerance, and resignation. I hope you notice that there are only women tonight talking to you or playing even music, except our musical prodigy you will listen to now. So let's turn to what YouTube has to offer today about musical prodigies. There are lots of them on YouTube, and I'd like to illustrate a few of them because they are not really playing classical music as tonight, but they are around. So this is Igor, who has been studied, and oh, I forgot to mention the book that you can see here just came out a few months ago. It's a very thick book published about musical prodigies. So for those of you who are really amateur, I invite you to read that thick book published and edited by Gary McPherson. One chapter was written about this boy who was discovered on YouTube but by my colleague Simone Dalla Bella. You have the reference at the bottom of my slides. And that was recorded when he was playing the drums at the age of 4. Amazing. I mean, what he can do at that age in terms of motor control, at least, the precision of what he can produce. And you can find also another percussionist from India, and you can find that again on YouTube, another musical prodigy. When I say musical prodigy, it's because they are recognized as such by the society. They win competitions, etc., before the age of 10. I'll come back to the definition. So Soham Goran, at the age of 9. So it goes on for a long time, that the kind of music. What you may not know is that it is improvised, but with strict rules, and it is qualified at the best, even better than the professional musicians who are accompanying him. And now at the age of 4, playing on the improvised tabla. So he has some feedback, but what I have been told is that she's singing out of tune, but he's really improvising along the rules of what it should be played. I don't know exactly what it is. It's a very sophisticated system, but it's not all. Hear him at 1 year of age. So, and so on. I'm not sure he could speak or even walk, but he can play. I mean, it's really remarkable. I find that fascinating, and I'm pretty sure that after this evening, you will share this fascination with me. So we wanted to, I mean, in that book that I mentioned before, there are lots of anecdotes, and many wrote about musical prodigies like Mozart, Mendelssohn, Menuhin, and the like, and there are tons of anecdotes about them, but very little science. So tonight, I'd like to illustrate what kind of science should be maybe done and what can be done with them and what can we learn by studying musical prodigies. So first of all is who can be considered as a musical prodigy. Not all of them will be recognized by the YouTube and the competitions. But there is a definition that is quite straightforward, that a prodigy is a child who at a very young age, typically younger than 10 years old, performs at an adult professional level in a highly demanding field like music. I forgot to mention that this work has been done in collaboration with Gilles Comeau at the University of Ottawa as well. So he proposed this definition, and I didn't believe him that it was possible, that of course we could distinguish the performance of a child from the one of a professional musician. So we took it very seriously and took the soundtrack of something like 100 musical excerpts from YouTube, either from a professional musician like Alfred Brendel, you know, that famous pianist, and a pianist, a child, prodigy, playing the same excerpt. And tonight you're going to be our participants. So you will see or hear the piano playing two excerpts, a first one and a second one. And your decision is to make which one is from a child. So you have to decide if the first one is from a child or the second one. And I invite you to vote on the computer outside at the intermission. And we'll give you the results after the break. So maybe okay. That was the first one. So you'll have to decide which one was played by a professional musician, a pianist, and the other one by a musical prodigy. Actually, it's going to be the same prodigy who will play for you before the intermission. But you have to guess which one. So if you do like we observed in the lab, here it's a natural experiment. In the lab, we tested many musicians, even experts in piano performance, who were really confident they can tell apart a professional musician, an adult, mature professional musician from a child. And even them, that's the orange box, were barely above chance. We'll see if you can do better. The non-musicians were completely at chance level, which is 50-50, yeah? 50 child, 50 professional. When they could compare one after the other, like you had, they were improving, so doing better. So in principle, you should perform above chance after the intermission. What you'd like to know maybe also is that what is really remarkable is that it's not really a question of hours of practice. The musical child prodigy progresses in 1 year, and on average, they succeed to succeed the examination, if you like, or to play the music that are considered to be for 2 grades in 1 year, while most of piano students don't even make a full grade level. So this is really fascinating because we'd like to understand how the brain of a child, a musical prodigy, can progress that fast, because what we believe in neuroscience, we'd like to understand, because understanding how the brain learns is really how to understand the human brain, how it functions. And also what is very important to note, and this is really a predominant view in the field, is that at that age, especially, you know, the Indian prodigy I showed you, he cannot have practice for 10,000 hours, because what it takes, and that's really the main lesson of teaching in a conservatorium, in the music faculties, is that it takes 10,000 of hours of practice, of deliberate practice, to make someone perfect, that is at the level of professional musician. These children cannot have achieved that many hours. Even if they perform many hours per day, they cannot achieve that number. Well, this has been really the dominant view in psychology for 30 years, that really we are all born equal, and that it's a question of practice. So if you practice enough, you'll get to the level of the quartet we just heard. Well, I personally don't believe so. I wish. So the idea is really that it is so Erickson was really the advocate of this point of view, saying that it is possible to account for the development of elite performance in music, but also in sports, among healthy children without recourse to unique talent, what can be called sometimes genetic endowment, accepting the innate determinants of body size. And this was really based on reports, that is the number of hours musicians were declaring, and it was clearly related to their level of achievement. So you have the number of hours on the y-axis and the years in age, and you can see, of course, the older you are, the more practice you have when you are a professional musician. The best experts practice more than the good experts, and all of them practice more than the least accomplished experts, and more than amateurs musicians. But there was a problem in these reports that was only criticized recently, because it was a sort of taboo in the milieu, especially in the music education milieu, that is that we don't talk about musical prodigies because that would not be appropriate politically or egalitarian view of music. Everybody should learn how to play music, and everybody can learn to play music. That's really the dogma. And of course, it's true, but there are deviations. And in those kind of reports, there was no consideration of attrition rate. That is, those who stop because they are not very good and they don't want to spend all their life practicing music while they are not really performing well. And this is really a fact for music for sure, for sports, for other activities. And so nowadays, it is really recognized that it's not only practice, it's not only made, but there is an important part of born. And we'd like to understand what is the born aspect, that is the predisposition factors that can produce musical prodigies, because of course it's a key to talent. For example, Ackerman just said that's really the big critique now of that point of view, that until Erickson, the guy of the 10,000 hours, shows cognitive expertise development in a randomly selected group of subjects, there is no reason to believe that such development can be accomplished. In the absence of such data, his claim should be taken with great reluctance, because also they may have highly disappointing results for the parents and others who have great hopes, but no data on which to base such hopes. And now the data are coming in. So I'm going to go very quickly reviewing the data. For example, this is a meta-analysis that has been published recently. Everything has been arguing for the inborn aspect or the talent aspect has been published over the past 2 years. So this is really recent and fresh. And in that study, they showed that really deliberate practice could account only, for example, for music is 21% of the variance. This is really minimum. All the rest is explained by other factors than practice. And there was a large-scale twin study as well, published from a team in Sweden. They have access to a large pool of twins. And what they showed, actually, that there was no causal relation between musical practice and musical ability. Musical ability was really tested by music perception tests because they tested so many twins. So it could not be done, on performance easily. So they had to test other abilities. And they compared monozygotic twins to dizygotic twins. What you need to know is that the monozygotic ones have 100% of their genes in common, and the others only 50, like siblings. And when you compare, for example, discrepant pairs, like monozygotic twins, one is really learning music, the other doesn't, you can see if it has an impact also on their abilities on their musical abilities, and they could not find any relation of this sort. But what they could find is that actually the desire, the musical engagement was genetically determined. So not everybody will be attracted by music and will be engaged in learning to play the instrument. It's really also genetically determined. That was also published 2 years ago. And another, so among all those factors that can explain the fact that someone will really devote so much time to musical activities so early in life, it has been proposed that these individuals have autistic traits, and that was the book published by Joanne Rothats in the US, and that's what she's calling the prodigy's cousin. And this is really the first kind of scientific study because that has been documented, and they have found some gene in common between autistic individuals and musical prodigies. But on the other hand, there is exactly the opposite view in the literature, also scientifically grounded, that openness to experience, so these are the people who are really socially adapted and interacting with the others, curious about life, predicts who takes musical lessons and for how long. So the more you are open to experience, the longer your experience you are taking musical lessons. So we have very different point of view for the moment. It's not clear what are the factors that are so important. But what is clear is that these children really get absorbed. It's atypical absorption in music. They can forget about everything else but the music. So for us, as a neuroscientist or neuropsychologist as well, musical prodigies represent a unique opportunity to reverse engineer the exceptional brain. It is a natural experiment. We didn't create those musical prodigies. They were created by nature. It's an accident, serendipity. And it is a rare chance to link brain behavior and genes. And of course, it reveals how the musical brain and how the talent is working. I mean, hopefully one day we will understand how it works. And relative to the brain predispositions now, what we do know and have accumulated a lot of data over the past 20 years, I would say, is that musical practice or musical training will shape the brain at different levels. And the question is really how musical prodigies start with. What is really their brain state when they start practicing? And just very quickly to give you an idea of how much musical training can change your brain, there have been many reviews, and really the musician is taken as a model for neuroplasticity. Neuroplasticity is another way to say that music is really changing, transforming your brain. And it does. Here, with the naked eye, you can distinguish the brain of a string player and a pianist only by observing that it is, that kind of omega is created by fine motor skills on the left hand for the string players, and for the pianist, of course, it is both hands. So you can distinguish them only by checking their brain, by checking the shape of the omega on both sides of the brain. Non-musicians don't have that omega shape, or at least not as marked as in musicians. They also have more gray matter, musicians compared to non-musicians, in many different areas of the brain. Here in color, so more gray matter means more neurons in those regions that are the frontal cortex and the auditory cortex, of course, as well as more fiber tracts that connect these regions together. And it is related to the number of hours of practice. You have those kind of schema. That is, the more you have practice, that is, the earlier you started also to play music, the more fibers you have in those fiber tracts that connect different regions. And the more fibers means that more the speed is enhanced or is faster in those connections. And also it has been done in children, and this kind of analysis of the brain. And they show that at the age of 6 years, those who had taken musical lessons for a year, at least a year and a half, I think, you could observe differences at the level of the auditory cortex, the right Heschel gyrus, and the motor areas that were thicker in the brain of those who were musically trained. But, there is a but. These differences were not due to random assignment. I mean, it's not everybody who will want to practice a musical instrument, especially at the age of 6. So these differences could reflect also genetic differences between these individuals who voluntarily engage in 1 year or 15 months of musical lessons compared to those who don't. There is still this kind of possibility. So we'd like to know more. Of course, we don't. I mean, the brain of musical prodigies has not yet been studied. We hope to do that in the coming years. And of course, what are the brain predispositions? Well, the idea is really that it's faster, denser, auditory motor connectivity to start with. And of course, it gets, with plasticity, it gets even faster and denser. One important question is how specific it is to music. Does it really affect speech, for example? Because we know that skills in one domain can sometimes lead to benefits in other domains, especially musical training for language. This is really the dominant view for normal individuals. I'm not in general, and we don't know about musical prodigies. But I believe that in musical prodigies there is a cost. So we'd like to know what kind of cost we can observe as well, because there is no free space at some point. There is a competition for space in the brain. So this is really the agenda we have for research. And in doing so, it's hard to have musical prodigies at hand to do those kind of brain imaging studies. So we will consider musical prodigies as the top 1% of their musical peers, especially those who have are the winners of competitions before the age of 10 or 12, as I was saying before. And this project is done in collaboration with Laurel Trainer. It's not by chance that we are organizing this evening, so at least that I'm talking about this project. And Sarah Lippé from University of Montreal. We are all interested by knowing more about the behavior and brain plasticity and genes of musical prodigies. So I hope that in a few years you will hear from us.